At its simplest form, a lubricant is a substance that reduces the friction between two moving surfaces. Lubricants can be liquids such as oils, solids such as graphite, fluid emulsions such as cutting coolants, semi-fluid emulsions such as grease, or engineered surface treatments. Some lubricants can also transfer heat, inhibit the oxidation and corrosion of parts, transmit power to do work, keep surfaces clean and contaminant-free, soften and condition seals, or more. A fluid lubricant can be classified by its viscosity, base oil quality, and the type and quality of its performance additive systems. The viscosity, otherwise known as thickness or resistance to flow, is one of the most important aspects of a lubricant, and it should match the needs of the application. Higher viscosity lubricants provide higher film strength and film thickness, and are required in systems with heavy loads, slow-moving parts, and shocks or vibrations. However, very viscous fluids may not be appropriate for parts where low-temperature pumpability is important or clearances are smaller, such as an automotive engine or transmission. Less viscous fluids also cause less drag as parts move and provide higher efficiency. Base oil is the building block of petroleum and synthetic lubricants. High-quality base oils have higher resistance to oxidation, oxidative thickening, and the formation of sludge and gunky deposits. They also have a higher viscosity index, meaning their viscosity is less affected by changes in temperature. More refined oils will typically have lower wax content, which allows them to flow more readily at low temperatures when wax begins to crystallize. They also tend to have lower volatility, or tendency to evaporate or burn off. This is especially important in engine oils. The type, quality, and balance of additives in a lubricant play a key role in determining the overall quality and suitability for particular applications. ZDDP, or zinc, is the most common anti-wear additive, and it's found in most types of lubricants. However, there is pressure on formulators to replace zinc with metal and phosphorus-free additives that are more environmentally friendly and less harmful to catalytic converters and exhaust systems. EP, or extreme pressure chemistries, help prevent cold welding, scoring, scuffing, and spalling, and are found in gear oils and grease formulations. Dispersants and detergents keep parts clean and prevent low and high temperature deposits. These additives work together to carry harmful contaminants such as abrasive soot and sludgy oxidation products to filtration systems and to prevent hard coking deposits on parts operating at high temperatures. Most lubricant formations will have antioxidants and corrosion inhibitors to prevent thickening and sludging of base oils as they degrade, and to neutralize acid byproducts of oxidation and protect parts from corrosion and early failure. Friction modifiers reduce friction, especially static friction, and can provide improved efficiency or can be used in transmission fluids to ensure smooth engagement of clutches and gears. Polymer thickeners can be used in oils to produce fluids that are less sensitive to temperature changes for multiple climates or seasons. And soap-based thickeners are typically used to give grease its semi-fluid structure. All of these types of lubricant additives are carefully balanced to provide robust protection and to meet or exceed the need of the machine parts being lubricated. There are advantages and disadvantages to fluid lubricants and greases. Both fluids and grease provide oil films, prevent wear, and prevent oxidation corrosion. Fluid lubricants also control deposits and carry contaminants and heat away from parts, acting as a cleaner and coolant. Incompressible fluids can also be used as a medium for transmitting power and doing work in hydraulic systems. Greases are not effective coolants, cleaners, or transmitters of hydraulic force. However, they offer several advantages over fluid lubricants. Grease adheres to parts and does not easily leak, remains on parts even when equipment is not running, and certain greases resist spray-off from water washdown. Grease can also provide a seal, preventing dirt and debris from entering bearings or parts. As we learned previously, The viscosity of a lubricant determines the film strength and film thickness of a lubricating oil film. There are several standardized classification systems for lubricating oils that differ for each class. The ISO viscosity grading system simply measures the viscosity of the oil at approximately 104 degrees Fahrenheit and is typically used for industrial hydraulic oils, gear oils, circulating oils, and turbine oils. The AGMA system mirrors the ISO system and numbers the most common viscosities of industrial gear lubricants, with higher numbers indicating higher viscosities. SAE J306 categorizes automobile gear lubricants by their viscosity and by their lowest recommended operating temperature. For example, an SAE 80W90 or an SAE 75W90 can be operated at temperatures as low as -40 degrees Fahrenheit. SAE J300 classifies oils by their viscosity and high shear rate viscosity at elevated temperatures, but also has a separate classification for cold ranking and pumping viscosity temperatures. These systems are used together to classify multi-grade engine oils. For example, an SAE 15W40 has a viscosity at 212 degrees Fahrenheit of between 12.5 and 16.3 centistokes and must pump at -13 degrees Fahrenheit and must crank at -4 degrees Fahrenheit. For greases, the viscosity of the base oil used to make the grease is important and helps to determine load carrying capacity, maximum operating speeds, and pumpability. However, greases are numerically classified by their NLGI number. Increasing NLGI numbers indicate less fluid and more product. The most common grease used for automotive and agriculture is NLGI number 2 grease, which is also commonly called gun grease. Knowing what a lubricant does, knowing how to classify different types of lubricants, and knowing what unique performance additives are found in different lubricants is the first step of the journey to becoming a lubricant expert.